Hello everyone, thank you for joining us today on Tuesday, April 24, 2018. Today's Uponor Academy webinar is titled Hydro Solutions featuring Weholite with our speaker, Mr. Darrell Sallenbach. Now before we begin, I'm just going to go over a few rules, a few notes. If there is any audio loss, please simply refresh your browser and you should be good to go. Use the chat box on the right to send us questions that will be addressed via email. All attendees will receive a 1-hour PDH certificate from Uponor, and then you can also check the resource box on the right for brochures, webinar schedule, previous webinars, or to contact the sales rep. Now without further ado, I'm going to pass it on to Darrell Sallenbach.
Well, welcome everyone to the Weholite Hydro webinar presented by Uponor. By way of introduction, my name is Darrell Sallenbach. I am a professional engineer in both British Columbia and Alberta, and also hold an MBA. I am the regional sales manager for BC Alberta and the Pacific Northwest. I have an environmental engineering degree from the University of Guelph and an MBA from the University of Alberta. I have been with Uponor for 17 years, and I'm responsible for engineering specifications and promotions into the wastewater, stormwater, irrigation, and hydroelectric markets. In total, I have over 30 years of experience working with engineers and end users on construction and design solution projects. The topics of today's discussion will be as I have here in the agenda. We will talk about the history behind Uponor, which used to be KWH Pipe, and the production of Weholite, how it's made, features and benefits. Then we will talk specifically about some hydro projects that we have built in the past. I'll bring you through to my web calculator and show you the modules that are within that and the tools that you can derive from that web calculator. And then for Q&A, I'll provide at the end of this presentation my phone number and my email address, and you can feel free to phone me anytime or send me an email with any questions that you may have. Uponor/KWH Pipe is a long-withstanding company dating back to 1929. Both Uponor and KWH were established in Finland, and in 1951 is when the company has decided to enter into the plastic manufacturing field, starting with floor tiling and then reaching out into plastic pipe. So we've had pipe in the ground since 51, and that pipe is still in existence, and it just goes to show the longevity and strength of this type of material for piping projects. After establishing itself as a major pipe manufacturer in Finland and other Scandinavian countries, in 1968, KWH/Uponor had purchased a facility in Huntsville, Ontario in 1968, thus beginning its venture into the North American market. Also in 1968 was the first year that KWH/Uponor had began to produce Sclairpipe. Following the opening of our facility in Huntsville, Ontario, it was determined that a second plant was required in order to meet the demand for polyethylene pipe. That particular second plant was then located in Saskatoon, Saskatchewan. Both plants are ISO certified. As well, they have fitting shops that can meet any type of application that a customer will bring to us. In July of 2013, the merger between Uponor and KWH was approved. And in October 2013, KWH is now exclusively called Uponor Infra Ltd. That concludes the history of my presentation, and now I will turn our attentions to talking exclusively about Weholite Pipe. Weholite Pipe has actually been around a very long time, around 33 years, and we began production of it in 1985. So what exactly is Weholite Pipe? It's a large diameter pipe ranging anywhere from 18 inches up to 11 feet on the ID. It's made from exactly the same material as our solid wall polyethylene pipe, except rather than extruding a solid circular pipe, we're extruding a profile, say for example 3 inches high by 5 inches wide, and we take that profile and we wrap that around a drum and we begin to weld the inside and outside of the profile together to construct the pipe. And so as you can envision, this would be a helically wound pipe. It's made to a very particular standard, and that would be to the ASTM 894 standard. So on this picture, as I mentioned, the pipe is made by first producing a profile, as you see on the bottom of the picture there, and we take that profile and we begin winding that around the drum. And as we're winding it, we're welding both the inside and the outside wall of the profile to create the helically wound pipe. And as I mentioned, the pipe diameters range anywhere from 18 inches up to 11 feet. And if it were shippable, we could even go larger, but we are restricted by the transportation and their regulations. On this slide, you see a sketch of how our pipe would look if you were to take a cross-section of the profiles away from the pipe and had a look at it from the end. You can see the black triangles there are our factory welds. And it's by no accident that on this sketch that the penetration of the factory weld is deeper than that of the actual profile weld. And that's what gives us the strength of the pipe, is the fact that these factory welds are actually deeper than the width of the profile itself. And that's what provides its strength. On this picture, you can see the worker standing at the end of the pipe as the pipe is completed being manufactured. You're looking at a 10-foot diameter Weholite pipe, likely in a 45-foot length, coming off the assembly line, getting ready to be shipped out and taken to the customer. All of our factories are ISO certified, both Huntsville and Saskatoon. And when we produce the pipe in accordance to that ASTM F894 standard, we are required to also produce the quality control records that go with that standard. So that would be, we can provide for you product quality records, mill tests. When we produce the pipe and or fitting, QA must sign off on that first. If we are producing fittings, then our fitting shop must sign off on the fittings. And then the last look at the pipe or fittings would be from our shipping department. As they're loading the truck, our shipping department observes the pipe itself, and if they notice anything that is not up to our high standards, then they'll flag it and bring out our QA people, and there will be some sort of recommendation as to what needs to be done in order to make that pipe perfect. I would like to now talk about the features of Weholite. First of all, size. Standard sizes are available from 450 millimeter or 18 inches up to 3350 millimeter or 11 feet in increments of generally 6 inches. So we'd go 18, 19, 21, 27, 33, 36, and then after that in every 6-inch increments, so 42, 48 inches, all the way up to 11 feet. Our Weholite pipe is made from exactly the same material as our Sclairpipe material is made from. HDPE does not corrode, and that you can see from that picture on the right-hand side that all those household cleaners, corrosive, acidic, whatever the case may be, are in polyethylene containers. And for that reason, that's why high-density polyethylene Weholite stands up to corrosive conditions so well. All our joints, when welded, are leak-free, and that's extremely important, especially in the hydro market, whereby every drop of water counts for power production and efficiencies. And having a leak-free system allows you to have the most efficient power production possible. Weholite pipe also stands up to abrasion extremely well. As you can see from this chart, Darmstadt had run a test, and he cycled 500,000 or 600,000 cycles of sand inside polyethylene pipe, asbestos pipe, concrete, clay, PVC, and then measured the abrasion. And as you can see by that graph, polyethylene came out the best. That is, it had over 600,000 cycles, very little abrasion. And that's important, and like in a storm market where you've got a lot of grit coming down the pipe, and you may also experience a bit of that in a hydro facility as well. And so we stand by our product very highly when it comes down to abrasion, and the operators of hydro projects in the past have not noticed any wear in our pipe, even over the last decade. The other feature of Weholite pipe is that it's a flexible pipe. It can tolerate differential settlement very well. We have a facility in the Tsawwassen area whereby they chose Weholite pipe because in that particular location they were going to experience high degrees of settlement. And also Tsawwassen is very close to Vancouver, which is in a seismic loading area. And they also wanted a pipe that's going to stand up to seismic loadings. And so for that reason, that's why they chose Weholite pipe for that particular project. Weholite pipe also has superior flow characteristics. As you can see in that particular photo, it is, in this particular project, we are relining a corrugated steel pipe after it has shown considerable wear and corrosion. And because of the manning coefficient of 0.01, we are able to actually reline corrugated steel pipe and actually increase or at least maintain the flow going through the smaller diameter Weholite. Weholite weighs about 1/10 of that of concrete pipe. And that has its installation benefits, especially on mountainsides where many hydro projects are installed. Contractors are looking for a light material that is easy to handle in these remote locations. And by weighing 1/10 that of concrete, your installation equipment requirements are greatly reduced. And that has massive benefits for a job site because it's much more economical to utilize a excavator than it is a crane. The production process allows for longer lengths. We can make this material in any length that the reline applications, the staging area isn't that large, so perhaps a 16-foot pipe length would be advisable in that particular instance. In other instances, room space is not an issue, so we can ship all the way up to 102 inches in 53-foot lengths, and our 108, 120, 11-foot diameter pipe would be shipped in 45-foot lengths. And as you can see, by shipping in as long a length as possible, that's going to minimize your number of joints, and that's going to minimize your shipping costs as well because you're getting more on per truck. It can also be nested. Weholite can also be nested. We've had several projects in the past requiring some 96-inch pipe for a hydro project, and then on an adjacent project, some 84-inch pipe. And we were able to nest those two pipe together and cut the freight costs in half. You could not do that with a material that would have epoxy coatings on it, because you'd remove those coatings when nesting the pipe together. And you couldn't also do that with concrete because it would be way too heavy. Both our facilities in both Huntsville, Ontario, and Saskatoon, Saskatchewan have fitting shops. And they can manufacture and fabricate pretty much any fitting that you require in order to complete your project. So what you're looking at here is 60-inch diameter Weholite bending through an elbow at 90 degrees and then being reduced down to 36 inches and going on from there. That particular fitting is likely going into a foul air system in a municipality, but we can make any type of fitting for any type of application that you need. In this picture, it's showing our 10-foot diameter or 50 millimeter diameter Weholite at 68 degrees. This is for a power project in around the Whistler, BC area. It arrives as one piece. They're not made on site. They are made in our fitting shop, delivered to the site, where it's then welded into place. In this picture, you are looking at a reducer. And this particular reducer is going to a power facility on Vancouver Island. And it's reducing down from our 10-foot diameter Weholite down to our 9-foot diameter Weholite. And you can see those bars on the inside. That will eventually be plated over, and in order to allow a nice smooth transition from the 120 down to the 108. You can see in this picture as well where we have aligned up the inverts of the 120 and the 108 inch, and therefore creating that sort of step in the reducer. So that's, if we didn't plate that over, we would have that step. And of course, with your flow characteristics, you can't have that, especially in a power project. So that's why we will plate that over and make it a nice, smooth transition. On this slide, you are looking at a 1800 millimeter by 1200 millimeter lateral going into the Annacis Island wastewater treatment plant. This was an expansion to the existing plant. You can see the two 48-inch pipe in the background there that we had to tie into that were pre-existing before the expansion took place. We then made a manifold for these 48-inch pipe to tie into, and once connected to the 72-inch, that would then carry itself into the fan room, which eventually would take the foul airs into a processing type chamber. The interesting part of this job was that being Annacis Island in Vancouver, we could not shut those trickling filters down for more than 23 hours. So everything you see there had to be welded up in advance and then lifted into place in order to meet this 24-hour schedule. And that's what was done, and the installation began, and within 23 hours, we were able to accomplish the task. Aside from elbows and reducers and air handling systems, Weholite gets used extensively for manholes. On the picture that you see there, the excavator is lifting the manhole into place at the Denver airport. Prior to the Weholite going into the ground, these particular manholes were concrete, and they just did not stand up to the corrosive soil that existed at the Denver airport. So the authorities decided that they would go all plastic, leak-free, and that's why they chose Weholite. On the left-hand side there, you see the top picture of a Weholite manhole with an H20 concrete ring integrated with it. And that's to provide the H20 loadings that may be incurred on some of these manholes within municipalities. The bottom or middle picture is showing how we can bench these manholes for whatever is required for making turns and things like that within the manhole. And then at the bottom, you can see where we've attached ladder into that particular manhole. So we can do ladders. If you need valves, we can provide all the brackets to mount these valves within, pumps, so on and so forth. We can easily integrate all that within Weholite with the advantages of having leak-free, corrosion-free manhole. Sticking with the vertical concept, Weholite can easily be made into a pump station. And we can provide all the appurtenances required in order to install pumps, ladders. If these are very deep, we can provide platforms as well. Your choice as an owner to use your own pumps, or we can provide them, and same with the control system. If you have a preferred vendor for your controls, then you're more than welcome to integrate that with our manhole, or we can provide the controls as well. The other novel item that we have on our pump stations is buoyancy control. We can design buoyancy control platforms, bases, in order to counteract all your buoyancy forces that are going to be on the lift station. And that has the advantage of the contractor not having to pour in place a base. Some of these installations are in the cold weather, like the one with the City of Calgary a couple of years ago. It was minus 30. They wanted us to design their lift station with a buoyancy control base, and so we did that, and they were able to just offload this lift station off the truck onto this mud pad that they had built, and without having to incur the cold weather conditions and having to pour concrete under those conditions. So very slick installation, made the contractor very happy. We are also able to produce Weholite in the form of panel. So rather than wind the profile around a drum, we're just simply extruding the profile and creating panels with this. And the advantage to that is that we can make rectangular tanks versus circular. And the big advantage to that is that if you have a small footprint where you want this tank installed, and circular is just not going to give you the capacity you need, or the capacity of a circular is not going to take up the space you have available, then we can definitely use a whale panel concept to accommodate your footprint. Weholite is also installed to a particular standard. That would be the ASTM D2321. So we're very particular about bedding and backfill. And if you as consultants or contractors are experienced with installing PVC, then it's the same specification for Weholite in terms of the ASTM installation standard. Weholite can be buried to 2 feet to 50 feet depth of cover. It is a structural pipe and can withstand H25 highway loadings. We can even do E80 loadings. We installed Weholite within a railway operation in Washington State a few years ago. Of course, the spec on that with every railway, I'm sure, is to begin with steel. And after a certain amount of corrosion is noticed, then rather than dig the corroded steel pipe out of there, they simply just relined it. But they did assure themselves through our web calculator that the pipe would meet the E80 railway loadings on that, and it did. We have a variety of methods at which to join the pipe together. What you're looking at here is our internal welder. This particular machine was made by Uponor Engineering out of Finland, and there are only 3 in existence in the world, and we have 2 of them in North America here. The internal welder sits inside the pipe, so there's nothing outside the pipe that you're using for welding. This has particular advantages if you're along a roadway and there's a fair amount of traffic going by you. then welding inside the pipe certainly has its advantages. So this is the machine inside the pipe. It looks like it's roughly 7 feet in diameter. We will take the adjoining pipe, band it, and then begin our welding process. And we should be able to get between 3 and 5 joints a day using this machine on something that's about 6 feet in diameter. After the weld is complete, the band is removed and onto the next joint. And this is a pressure joint for our hydro projects and or the irrigation market as well. And so this joint is very, very strong. This is another picture of the internal welder showing the technicians at work. It takes 2 technicians to operate this. All our technicians are factory trained by Uponor and fully capable of operating this machine. They're also very good at troubleshooting, and if for some reason temperature conditions aren't right or there's moisture in the resin for whatever reason, our experienced, highly qualified technicians can observe this and take corrective action as required. Here's a picture of the weld that was produced by the internal welder. You can see the resin goes right clear from the inside right through to the outside of the pipe. And that's why we have to use that band to keep the extrusion from pouring out across the outside of the pipe. The weld itself is full profile and therefore much stronger than the pipe itself. You can see the comparison of the weld done by the internal welder versus those little black triangles that are the welds that are produced in the factory. Also, in addition to our internal welder, we can weld this pipe using our handheld extrusion welding technology. And this is the technology that we used before we had the internal welder. And it's also technology used on lower pressure applications. We just finished a project in Oregon whereby the welding was being conducted on a pressure pipe running at 7.5 psi. And we were able to accomplish that with just our ID welds, as you're seeing here. Did not need the use of the extrusion welder. The advantage, if you can use the extrusion welding technology, is that there's thousands of these guns available throughout North America, where the availability of the internal welder is quite limited to the amount of machines that we have. As I mentioned before, a welded joint is extremely beneficial in areas of soft ground conditions, areas with high settlement, as in the Tsawwassen project, and in areas of seismic activity. So that's pretty much all the way down the west coast of North America. If you are designing a Weholite piping system for your power project and want to get specific on the welding of the pipe, then we have these specifications that you may use in order to specify the type of weld you would like to see on your project. And that's pressure dependent. So up to 7.5 psi would be your just ID weld. And beyond that, we can use the internal welder or an ID and OD weld. But for most projects, they don't get that specific. So just by stipulating the pressure and extrusion welding, that would be enough for a manufacturer to base their welding estimate onto, and for the contractor to understand what type of weld is required. We also have, in addition to our welded joint, a threaded connection. The thread is connected in our factory by removing the outside profile wall of one end of the pipe and the inside profile wall of the adjoining pipe. And that's the advantage of a helically wound pipe, is that you can create these threads. The threads joint is not leak-free, but it is silt-tight. And it's an excellent application for culverts because they don't need to be leak-free in 99% of the cases. And because it can be performed by a contractor without having a Uponor technician there to weld it, it's very contractor friendly as well. We also can offer a band coupling. And this particular band coupling is not only pressure rated, but it is leak free. The advantage to the coupling is that if you are in a trench where there's considerable water and you can't dispose of the water, say you're on a side street doing a sanitary sewer project and you just have no place to put any groundwater that you're coming across due to environmental regulations and such, that they can use this band. And the reason why you would want to use the band is because you can't weld in wet conditions. So this is why we offer this band. It is quick, it's reliable, contractor friendly, and it gets the job done as well as the welded joint. We also offer a flange connection. Flange connections are often used going into concrete structures or into a joining pipe. The reason why you'd want to use it on a joining pipe is that, especially on a power project, you're going to pressure out at a roughly 22.5 psi on our Weholite, and most power projects require pressure much, much beyond that. So why even have that type of connection? Why use Weholite? Why not all steel? Contractors love the material. It's easy to use, it's light, comes in long lengths, joints are reduced, and you can nest this pipe with a smaller size and not worry about the coatings on it. So it's very economical, not only to install, but also to maintain. I've done several walkthroughs on power projects that have been installed for 10 years, and there's absolutely no detriment to the Weholite pipe at all, whereby on the steel you have to be very careful during your inspections to make sure the coatings and everything are intact, and if they require repairs, then there's going to be a cost associated with that. Weholite, you simply do not have that. The question often comes up, how do you connect to other materials, say a concrete manhole or existing PVC or concrete that is currently in use and would have to tie into the Weholite pipe? Well, in this sketch you see here, details how those connections are made. So in the case of concrete, we would remove the outside profile wall, wrap that with a red rubber Adeka gasket, which we have specified on this sketch. Then the contractor would just grout that annular space, and you have a leak-free, fully restrained joint connection to concrete. In many instances, we are required to connect to PVC. And in so doing, we can use what is called an inserted T. An inserted T is just exactly what you see there, and our technician would cut a hole into the Weholite, and it just allows you to plop this inserted T into the pipe. And the contractor is free to do that themselves because Weholite is quite easy to work with. The limitations are that it's only available up to 900 millimeter, and many lateral connections are much larger than that. So for that, if you have an existing PVC pipe or concrete that it goes beyond the 900 millimeter, then we would concrete encase that, very similar to what we did with concrete. And we have sketches and details on how that connection can be made. For our irrigation projects, we are asked to supply sometimes 8, 10, 12-inch, 18-inch diameter lateral connections, and with those we provide a flange connection to allow you to tie in downstream to your existing pipe. As you will see from the other sketches that I have provided in the past, that Weholite is a dual wall pipe. So it's very likely in the event that a forklift should hit it or a shovel or something penetrates the outside wall, there's a very good chance that the inside wall will still be intact. So maybe under a seismic event, you may have, for some reason, a rock that shakes up against the outside of the pipe and creates some damage, but it's very unlikely that it would go through to the other side. So there's a certain amount of advantages to using a dual wall pipe for sure. We can fill the annular space with grout, and the advantages are there. We can go very, very deep with Weholite, and I've seen some landfill manholes that are 60 feet deep, where the last 30 feet was filled with grout in order to give it the stiffness we needed with those soil loads back onto it. And if there's anything that would happen to the pipe along the way, or just, you know, through wear and tear over the years, then we have local sources available that we can come out and make any type of repairs with. It's becoming more and more common for consultants to specify some particular type of joint testing. And on many occasions, we do just state a visual inspection because our techs are very well trained in noticing a joint that may not be correct. They will notice the color of the resin may be off a bit, maybe kind of looking a pale white color, or perhaps even a bit bubbly. That would be from moisture within the resin. And if they see that, they start welding, find the problem, and then grout or route out the old joint and then re-weld it. And that's what happens when we have our visual inspection. We do notice things like this that we can make and take correction action on. Another joint test is to simply remove a coupon. And as you can see here from before, we take a sample from this weld. This is our internal weld that we have made in the past. And we take a coupon out, generally speaking, 2 inches wide and 12 inches long. And we take that and overnight it to our lab to do a tensile test on it. And it will break, but it can't break at 15 MPa or less, or it's not considered successful. And it can't break at the weld because we state that the joint is stronger than the pipe itself. And we can state that because there's more material in the weld than there is in the actual factory welds. So we can't have a break at our weld, field weld. If there is, then obviously we have to take some corrective action. So we generally test every 5% of the joints. So there's this project that we just concluded a little while ago, and we were asked to take three coupons, one at the beginning of the project, one at the middle, and then one at the end. And they all passed with flying colors. And like I say, our minimum tensile pull on that would be 15 MPa. So we like to see it close to 20, 25 MPa. Another test that we can do, and this is becoming more and more popular, is an air test. You really can't see it from this photo, but I'll describe it to you. It's 2 bladders, and in the middle, there is a gap. The 2 bladders fill up with air on both sides of the joint, and that's creating your seal. And then this other gap, this third gap, is just at the joint itself, and that's where we actually inject the air at a certain pressure. It's 8 psi for 3.5 minutes, and we can't see the pressure drop for more than half a psi in that time frame. And most of our joints, or all our joints anyways, being welded, we have no loss in air pressure during this test. The machines run for roughly $25,000, and there's 2 manufacturers, Lancis and Plugit, and both those are very good companies that we like to utilize. I believe both of them are out of California. But that's becoming more and more frequent, and with this joint test, you can do it on every joint, not just like 5% with a coupon test. So quite a detailed test. Uponor also provides full installation support. Our technicians are all factory certified, and when they're not in the field, they're in our shops, welding up Weholite and gaining experience that way. They're great problem solvers in the field. They're Uponor employees. They're not a subcontractor in any way. And we can also provide an on-site engineer thus ensuring the proper installation from the beginning to the end is maintained. I would then like to turn our attention to Weholite hydro projects. I'm just going to focus on hydro projects, but you do realize that we can reline culverts, we can produce tanks, we can do storm and sanitary sewer projects. We also do irrigation projects. We offer lift stations. But for this end of it, since it's a hydro webinar, we're going to just focus on hydro projects. So I'm going to present these hydro projects in chronological order. Beginning with Pacific Core in year 2000, we did a hydroelectric water supply project in Big Fork, Montana. This is large diameter. I believe it was 10 feet diameter, operating up to 8 psi. They wanted something with a tight, reliable joint because it was a hydro project. Every drop counts. They also wanted something with excellent flow characteristics, and the longer lengths reduced the time on site substantially and reduced the shipping costs as well. And they also wanted a material that was corrosive resistant, and Weholite meets all those criteria. For the Pacific Core project in Big Fork, Montana, you can see on the right the channel that was existing, and that's what they wanted to replace with pipe. And the reason being, there's a safety issue, so they wanted to close it up, prevent people and animals from entering it. It was also filling up with sand and silt, and they wanted to alleviate that as well from going down into the penstock. And of course, they wanted to keep evaporation losses to an absolute minimum. And by casing this particular canal with pipe, solved all those problems. You can see the front end of the pipe just as it's being welded together and under construction for the Pacific Core job. This particular pipe was 120 inch with a ring stiffness coefficient of 250. The ring stiffness coefficient is the particular stiffness of the pipe, and it's that parameter that you enter into our web calculator to determine the loadings on the pipe. And it also, the ring stiffness, tells you what sort of pressure that this particular pipe will withstand. Being at 8 psi, we had to do both an ID and OD weld on this pipe, as the internal welder that we normally would have used was not built or designed yet. The next project is the Rutherford Creek Cludworks project, built in 2003. Low pressure, 15 psi before tying into the steel penstock with a flange. This project is located up near Whistler, BC, and it was roughly 5,000 feet of Weholite pipe before being flanged into roughly 8,000 feet of steel pipe. We did a walkthrough on this pipe a few years back, and there is no detrimental effects occurring on this pipe due to any sand or abrasion, no corrosion issues whatsoever. They're very happy with the way it's performing, and its maintenance cost is so low. This particular power project is producing 50 megawatts, and this Weholite pipe is a good reason why. The next project is Fire Creek, where the owner is Interjex, and 84-inch Weholite was the pipe being called out for. And this particular project was built in 2008. Fire Creek is located in British Columbia, up near the Harrison Lakes area. It was quite a remote site. You had to drive to Pemberton and then take a 2.5-hour logging road journey to the actual site. And so it was a camp job. Remote location, and there was no problem getting the pipe there whatsoever. Even in these remote locations, we can barge it and or railway it, or use trucks if trucks are available. The next project I'd like to talk about is the Douglas Creek project. This is also an Interjex project using 96-inch diameter Weholite, and it was constructed in 2008. If you recall from the last slide, the Fire Creek project with its 84-inch diameter Weholite. Since both projects were installed in roughly the same area, we were able to nest the 84-inch pipe inside the 96-inch, therefore saving a lot of money on transportation. The third project in the cluster of three is Tapella, also with Interjex. And all three, Douglas, Fire Creek, and Tapella, are located on the Harrison Lake area. This project required the use of 66-inch Weholite and running for roughly 3,000 feet. You can see on the Tapella project, as with any hydro project, the flange connection. So running at roughly 15 psi, we pressured out with the Weholite and now going into steel thereafter. And the advantages of this is, why not just use steel? Well, the economics of Weholite are so inherent. It's a light material. All these power projects are built on mountainsides. So you want something easy to handle. And the longer lengths make up fewer joints. There is no corrosive coatings to worry about, and very easily to maintain. Next, we have the ABERFELDIE project. This is a direct project with BC Hydro. Up until now, the previous hydro projects have been with private developers. You've probably seen PacifiCorp, Cloudworks, Interjex in the titles of the slides. This one is directly with BC Hydro. However, all those other hydro projects are connecting to the BC Hydro grid. This is our first 132-inch pipe that we made. It was specifically for ABERFELDIE BC Hydro. And they asked us to come up with this particular diameter pipe because they needed it for their flows. And so we did. And so this is our first installation with 132-inch Weholite. It's working very well. They've had recent inspections up there, and all the joints look tight. They're not noticing any wear and tear, no corrosion, no abrasive issues to worry about whatsoever. This project is located in the Cranbrook, British Columbia area. And it was an upgrade. They've gone from 8 megawatts up to 28 megawatts in that particular project. And there will be a flange connection going into the steel pipe further down the pipeline. Our next project requiring Weholite for Penstock was the East Toba project. East Toba is located about 50 kilometers north of Vancouver, BC. This was a very remote project requiring access only by float plane or by regular boat or barge in the case of when material had to be shipped to the site. It had a camp with roughly 350 people at its peak, and the project was built in 2010, requiring about 3,500 feet of 120-inch Weholite, running at around 15 psi. The owners of this particular project is ALTERRA. If you see in the corner of that picture there, the Weholite pipe where the skin has been pulled back, they're getting ready to pour a concrete intake structure around that. And as I explained before, they've removed the profile wall in order to make this connection into the concrete so that when it dries up, it's got a fully restrained joint, leak-free joint at that particular intake. Our next Weholite project is the MONTROSE Power Project, also owned by ALTERRA and also located 50 kilometers north of Vancouver, BC, and sits adjacent to the East Toba project, the project we just talked about. On this particular project, there wasn't any Penstock requirements for Weholite, but they did use our 132-inch RC 250 Weholite in order to serve as a structure, so they did not have to pour concrete in this particular facility. There was an instant where this particular project at one time a year was under avalanche conditions, and all our techs had to go through specialized training on this particular project where avalanche conditions were very high. Next, we have the Kokish project, owned by Brookfield. Kokish is located on Vancouver Island, about 5 hours north of Victoria, BC, in a community called Port McNeill. On this particular project, there's roughly 3,000 feet of combined 132-inch, 120-inch, and 108-inch RC 250 Weholite. As you can see from this picture, we are reducing down from our 132-inch to our 120-inch, and that's the reducer that you're looking at in there. This project was built in 2012 and remains one of our most current power projects to date. That concludes the presentation of the Weholite case studies on power projects. However, you will recall that we do have a handful of different applications for this material. One of those would be for roads in culverts, which you have seen from my presentation. As you're going up to your powerhouse or using any of the road networks within your power facility, you may be finding that your culverts are deteriorating, and you may have thought of digging them out and replacing them. Well, just remember that Weholite can also be used as culverts on your roads. We also have the stormwater retention detention systems, which you may need at your power facility. So please keep all that in mind. But I'd like to turn our attentions now to our website and our web calculator. Our website can be found at uponor.ca, and on there, there's a host of different things that you can look for. It has a search engine for technical information, case studies. You can go through all the other applications that I've been talking about in detail with brochures included. So have a look at that, and if you have any questions on it, please get back to me. I will give you all my contact information at the end of this presentation. Next, I would like to talk about the web calculator. The web calculator is a very useful tool for consultants, contractors, anyone who's designing a power project. You access our web calculator on our website, uponor.ca, and towards the middle of the page, you'll see this icon. Calculation tool, it's called. Click on that, and it'll lead you to the next page. Once you've clicked on the calculator tool icon, you'll be led to this page. And this is where you sign up for our web calculator if you haven't already. It only takes a minute to complete, and you get approval within a couple hours in many cases. So it's very quick to sign up and very quick to be accepted for. Once you have signed up, you'll move to the tool itself. So once you've signed up for our web calculator, you'll be brought to this page. And you'll see across the top both materials that we manufacture. One is Weholite, the other is Sclairpipe, and along the side are the modules that you can use to determine the design on your particular penstock. So we have, which you can utilize right now, pressure fluid flow, gravity flow, that's certainly more with the storm and sanitary applications. Thermal effects, certainly always a consideration when you're especially tying into structures. You want to know how to control that, and we can provide advice on that. Buried pipe design, that's where you put your loadings in above the pipe, where the groundwater table is, and if you've got any H20 loadings or other traffic loadings on the pipe, you can assess it there. And if you're in a situation where you have shallow cover, the web calculator will say too shallow for analysis. But don't let that stop you. Come to me, and we'll send your inquiry into engineering, and they've got 3 or 4 other different models that they can run in order to assess your shallow cover. And we also have tables that I can provide for you right now. So don't let that output keep you from running your calculations. We can do wall buckling with these modules and allowable bending radiuses. Bending radius of Weholite about 200 times the OD, and that by comparison for Sclairpipe is about 35 to 40 times the OD, depending on the dimension ratio. Now, there's other modules in there that you cannot enter and utilize, like the pipe pressure rating, the surge assessments, support spacing, marine applications. That's all done out of Finland, the marine installations, the safe pull strength and manhole riser design. But if you need information on that, I would run it by our engineering department, and they will be able to make those calculations for you. And lastly, I just want to provide for you my complete contact information. There's my name, Darrell Sallenbach, my email address, and of course my phone number. So feel free to get in touch with me. If you can't find the information on our website, I will have it. I've been doing this for 17 years and carry a lot of information with me. So give me a shout anytime, and I'll make sure that I get your information to you or answer any questions that you may have. If you have any questions regarding this presentation, please get back to me when you can. Send me an email and with a question on it, or give me a call at 604-312-5829, and I'll make sure you have everything you need. And it's been a pleasure providing this information to you, and I look forward to hearing from you sometime in the future. Thank you.